No, first. Yeah, so today we are going to continue. Let us run this program. We are going to continue on linear regression. Yeah, I asked the question that what is linear regression? And if we can read together, we said regression is a statistical approach to find the relationship between the variable, and the linear regression assumes a linear relationship between what variable depending on the number of input variable. The regression problem classified it is being classified into two types. We have linear regression, we have multiple linear regression. Are we there? So now, okay, we have now take an example of a business problem in this article. We say let's consider there is a company and it has improved the sale of the product. The company spend money on what a different advertisement. So the company now intended to improve the sale of a product and it spend money on different advertisement. And the advertisement means such as what TV, radio, and newspaper. So they say to increase the sale, they intend to increase the sale of the product. The company record the money spent on each advertisement. Are we there? So now our objective here is they say now we have to help the company to find out the most effective way to spend this money on advertisement media to improve the sale of the next year with a less advertisement budget. So the company does not want to spend too much. So we need to find a way that we need to help the company to spend this money, and how is it going to improve on advertisement. Okay, because the company wants more sale, so they are asking on how to improve on advertisement. So we are going now to work on what? On linear regression and multiple linear regression, and we choose which of them are the best. Okay. Yes, so by doing so, you have to do what? Input pandas, right? Input pandas as PD. Then we also need to input numpy numpy as np. We also need to input matplot library dot pyplot as plt. We also need to now, since we have to use this library, we have to use scikit-learn. Okay, we have to use scikit-learn for linear regression, and we have to use scikit-learn for what? For square error. That for mean square error. For mean square error. So we have to do what? We say from slen linear linear model. Yes, linear model input linear regression. Input linear regression. Input linear regression. This one, bring this one back this way. Input linear regression from scikit-learn metric scikit-learn metrics import mean squared error, mean squared error, whole square score. Yeah. Yes, so we run the program. Then from there, now I have sample data. So this is my data. Okay, this is TV. These are the various data from TV. We have radio, we have newspaper, we have sale. Are we there? So at this point, you have to know how to start continue. Let's first of all run this data. After we run this data, we create data frame. So we have to, after running it, we have to create the data frame. Okay, so you have df, create the data frame. Df is equals to bd dot bd dot data frame to the data frame. Now fit in now the data inside the data. Now we create, so these are the data, this is the information for the data. So we have to create the data frame. Then next we have now to do what, the independent variable. We have to reshape various independent variables by using what, scaling. So independent variable, so independent variable, we have what, x, we have x is equals to df is equals to df. At this point we have to, the independent variable, we are going to start on what, we are going to start on simple linear regression. Okay, at the first objective we start on simple linear regression, then later now we are going to move on to multiple linear regression. So for us now to start on simple linear regression, we are going to define x now. X at what, TV. This is TV. D, this, and we get dot value. Now we have y, df, we have df series, dot value. Okay. So the this point now we define now x, y. So our x is the how the TV advertisement of TV, how is it going to influence the sales? Are we there? So, and also this is for what, simple linear regression. We wanted to find how advertisement of a TV will influence sale. Okay. Yes. So when we do that, we have to do what? We have to fit the regression model by doing what? So we call model is equals to, the model is linear regression. Linear regression is linear regression. So we write now model dot fit. So we have X is capital, fit X and Y is small letter. X is capital, Y is small letter. And when we do that, what do we need to do? On it, finally we have what we have fit linear regression. Yes. So when you fit the regression model, you will see it this way. Linear regression model has been fit. Then from there, we continue. So we have to do what? We have to make prediction. Okay. So for us to make prediction, we can call y predict, or like y breadth is equals to model dot predict model dot predict x, model dot predict x, capital X, don't forget, model dot predict x. Yes, after when we do that, we have run it. The next step, we have to print the coefficient. Okay, print the coefficient. So print coefficient, print intercept, yeah, comma, you print the intercept of model dot intercept, print coefficient, of this coefficient, model dot coefficient coefficient 0. Yeah. So we have when we have the intercept of 7.33, we have the coefficient of 0.04. Yeah, let us move forward to bring the performance matrix. Bring the performance matrix. Now printing the performance matrix, let's print performance matrix. So we have to print the mean, mean square error, capital M, capital S, mean square error, bring the mean square error. square error, least square error of what? Y, y predict, y and y predict. Okay, so now here we have y equals to c. Y is c. So now this is what we are looking for. We are looking for c. So at this point now we are about to do what? To print the mean square error for y and y predict. So now on y predict we have what? Y predict equals to we have run model to print x. So we wanted to predict the x value, that's the TV, that's if the advertisement using the TV will increase the sale. Okay, we continue to print our whole square, our print our squares. So to print our square, we have our square, our square squared, square squared, square of what? Y, y, and y predict. Okay. Okay, now we have print the mean square error of 9.24 and the average square error of 0.6. Let us move forward to plot the regression line. Plot our regression line. Plotting the regression. Now, on plotting the regression, we have to do what? Plot the scatter plot. We have to plot the scatter plot TF. So we have TF for what? TV. Scatter plot F. TV is capital letter. TV. F of TV, capital letter. Then we have also, we wanted to plot the scatter plot, the F of TV. We have the F as the data frame of also sales. The sales should be in capital letter because in capital letter. The F of sales. Then we have TF. Since we are doing with linear, just on one, not on multiple, we have just TV and sales. So what it makes, we have color. Color is equals to say blue. It's a blue. Color equals to blue. Is a color is equals to blue. Over there. Then we have plot. PLT dot, that's X label, X label, X label, X label TF. Yeah, of TV. X label DF of TV. Mm-hmm. We have y predict color equals to right. That's our X label. Then we go now. What next? We plot plt dot y label. Okay, on y label we plot what says capital letter says says yeah in dollars. In dollars, let's say 1,000. 1,000 says in dollars. Says in dollars. Also, let us also fit this one also. In dollars. To continue and plot plt dot y level on our y level. We have says s says in dollars. $1,000 unit. And we have again we have plot title plt dot title. So place our title says versus that is spend. This is spend. And we will do that. We have plt dot show. So now we have written the program. Plot the scatter plot of TV, DF data frame against TV, data frame against cell, color blue. Plot plt plot DF the TV, y predict color. We have plot the X label, plot PL Y label, the title and show. So when we run it down, we are going to find what these various information that we have listed here. We say we should plot the scatter plot. This is a scatter plot of what the TV against cell. Okay, we say we should plot DF of TV dot y predict color red is predict this color is here. Well, let us change this color. Let's change the color to green. See this color, the line now became green. Are we there? Then now, if you look at blue, this blue is this dot. Are we together? This predict dot. Then also, if you look at again at the point of we have plot the X level TV advertisement spend. Plot the X level TV advertisement spend in dollars, $1,000. So this is it. We have it here. Then we say okay, plot the Y level of sale in $1,000 sale. Then also we have what plot the title. This is the title, and we have now plot the show. Plot the show now give us now what? Give us now the entire diagram. The entire diagram. Okay. Yeah. And to recap now, what we have done, right? Yes, from the beginning, this is our problem. We said what we define linear regression. So and we work on what simple linear regression. And the simple linear regression, this is our problem. So we say let's consider the company of this. So the company has what the sell, and also now we have the TV. We are predicting the sale price. So the TV, the radio, the newsletter. So and also newspaper increasing in sale. So now at this point now we use now what the TV, the TV television advertisement is of sale to predict. So now we have what to do, what we create the data. When we create the data, we have what X versus Y. At this point now data versus TV and sale. So we fit now the regression. When we fit the regression model, after fitting the regression model, we make the prediction, Y prediction. Okay, then we print the coefficient, the intercept coefficient. So we have the intercept coefficient of 7.33, we have the coefficient of 0.4 or 0.04. Then now we print the performance metrics. Performance metrics, you have the mean square error, you have 9.24, and the arrow square of 0.6. Okay, then from there we plot the graph. So after drawing this, let us recap. We have this. Okay, now if you look at on we see what I say, you can see that the predict sale column value are calculated using what the equation of a line. So now at the equation of a line, y equals to mx plus c with what m, we say m is equal to 0.45, and we say c is equal to 7.33. Okay, so now at this point we have calculated what the intercept. We have calculated the intercept. Let me show you guys. With the coefficient, we calculate the intercept and we calculate the coefficient. Are we there? So now the intercept give us 7.33 and the coefficient give us 0.046. Okay, so now we are going to use now the intercept and the coefficient in order now to predict now the word, the sale. Are we together? Because our objective is to predict the sale. So what are we going to do? We use now this equation y equals to mx plus c. Now with the equation of a line, y equals to mx plus c. At this point, y now is the sale. Okay. Okay, now we have now the mx plus c. The x now is the advertisement. Okay, and the m we have already worked. Now the m, now you have now to do what? You substitute now the value for m and the value for c. The c is the intercept. and m is the coefficient, because if you look at it here, we already calculated those things. At this point here, I say that what y equals what, you fit now this value 0.0465 multiply by what, by TV plus 7.33. So now I say, for example, for the following, TV is advertisement expenditures. Now advertisement expenditure of X, we have 2301 for X. So if you look at advertisement expenditure, now TV 2301. So now you come, now you take now this expenditure 2301, yeah, 2301, you fit it where you see advertisement expenditure. Yes, when you see advertisement expenditure, because we say this multiply by this, so you take this now multiply by 2.2301 plus this. Are we there? So it gave us now 18. So this is the predicted value of 18.0648. Okay. Yes. Then now I say y equals to, say, to remind you guys, I say by comparing the predictor sale with the actual sale, you can see that the linear is fit to the data. The difference between the predicted and the actual sale indicates the error. Now at this point, now we have already calculated this by feeding this value, and finally we have what, our prediction. Yes, as I said that really, let's run this. Yeah. So finally, to recap now, we have plots the various TV sale and predicted sale. This is what we have predicted. Okay, so how do we do that? We see that this equation of a line y equals to mx plus c. So TV is x, TV here is x. Are we together? Then now sale is y. Then now predicted sale is what we are looking for. We have 22.1. If the sale is 22.1 and if the TV is 230, so if you look at the sale 22.1 and the TV is 230, if the sale is 22.1 and the sale is 22.1 and the advertisement is 230, then the intercept is 7.33. The coefficient is this. So what are we going to do? We substitute now the value inside here. When we substitute the value inside here, we are going to have this predicted value 18 point. So we move now again to the second line of if the television advertisement is $44.5 and the sale is 10.4, what will be the predicted value? We substitute and we are going to have 9.4. So this now are the various predicted value. So if now you need to know if at that point where the predicted value are corresponding with the sale value, you know that it is good, because like for instance, we have 22.1, we have 18, it's different. We have 10.4, we have 9, it's a bit nearer. So we have all these things because our mean square error is down. If you look at our square is down, is 0.6. So when we have high R square, if it is 0.9, we are going to see that our sale, our predicted value will correspond the same, it will be corresponding closely the same to the sale. But if now we have our R square to be 1, obviously mean that the predicted cell will be the same as the cell. If this R square is equals to 1, the predicted cell will be same as what the cell. But since the R square is less right up to 0.6, there must be a gap of difference. So always make sure that your R square is at least close to 1, but it's not possible for it to be 1. Okay, yes. So you see we have already substitute everything. So I said y equals to c. I've done substitute. So if I had this value, so I fit everything. C equals to this accuracy. So I've done everything. Okay, yes, take care.